Yeah? I've got a thumbs up, so I'm going to assume it's working. Shout at me if it's not. Hello, everybody. Thank you all for coming. It's very early, but Naomi's talk was ahead of mine, so I felt like I was going to get decent attendance. Naomi's talk is solid. So.
Fill the phone, please.
Or let me answer it. Either is fine. Okay, cool. So quickly, if you want to talk to me either now or later, you can hit me up at these places. There is usually a good game of trying to tweet speakers mid-talk to see if they'll get notifications popping up on the screen so you can see your name in lights. That's not going to work this time, so don't do it. Please only tweet me abuse and save it till after the talk so I definitely see it. Quickly, a little bit about me. My name's Cory. I work at HP. I'm employed at HP as a senior cloud engineer. My actual job there is to not do very much cloudy stuff, but instead to do lots of Python open source work. My goal is to improve HTTP in Python open source as much as possible. That's quite a lot of fun. In and around that, I do lots of little Python open source HTTP things, the things you're most likely to know. I'm a core maintainer on the requests project. I'm a core maintainer on the urllib3 project, which is just about as important as requests, but none of you know what it is. And I maintain a number of other various HTTP-related projects. If you want to talk HTTP or HTTP2, come find me. I've got lots of demos and interesting things to show you, so that should be fun. All right. This talk is a dangerous one because it's 90% my own personal opinion. If you come to conference talks because you like facts, or if you are afraid of opinions that differ from yours, this is a dangerous talk to be in. The door is there are doors there and there. There are probably other talks with actual facts in them. I'm just making stuff up as I go. I won't be offended if you leave. Okay, cool. So I've got about 20-odd minutes, so let's try and talk about simplicity a little bit. So before I charge into this talk, I think we need to get some common ground, and we need to see if we actually all agree on what simplicity actually is. It's a simple word with quite a lot of depth to it, and when we apply it to software, we're not all talking about the same thing. So I'm going to use a few examples of what I'm using simplicity to mean in this talk so that we're all on the same page. This is a steering wheel. People use it to steer cars. Sometimes people use it to steer other things, but this particular one is from a car. I think I can safely say that everyone in this room understands steering wheels as an input device. Yeah? Anyone think they don't understand steering wheels as an input device? Good. That's helpful. I won't have to explain them. More importantly, most children, certainly children who are exposed to cars when they're relatively young, also more or less understand the steering wheel as an input device. There's some complexity around the interactions of the steering wheel and the road, so you wouldn't want a child who's seen a steering wheel to be driving a car in reverse. That would be bad. But generally speaking, they mostly understand how the steering wheel works. It's a sufficiently simple device that children are pretty capable of using it. This is also a steering wheel. This is a steering wheel from a Formula 1 car. This is not a simple input device. This is an extreme example here. These are two devices that serve a specific purpose. One is very simple, and one is very complicated. Complex is actually the word I'm going to use here. Complicated is another tricky word, Zen of Python, blah, blah, blah. Let's use complex. This is a mouse. This is a simple mouse. It has a button on it. This is also a mouse. This is not a simple mouse. It has many buttons on it, and some crazy DPI controls, and all sorts of total weirdness. So if we use that as a kind of a setup of examples of what I mean when I say simple and what I mean when I say complex, let's turn a little bit to software. I'm going to use requests again because I'm deeply, deeply partisan, and I only like to talk about my own work. This is requests, and this is some simple code. This is urllib2. Which is a library that does the same job. And this does the exact same thing as this. They are the same in terms of what they achieve. This is not simple. This is complex. Complexity in here comes from a lot of places, partly because my screen's not wide enough to keep it all on one line, so there's some interesting indentation work going on here, partly because you have to understand what a HTTP password mugger with default realm is and what it might do. None of this is immediately obvious to most people. It is complex. I think what we can begin to agree with for at least this discussion is that even if I couldn't necessarily put into words what simplicity is well enough for this discussion, I and if people in the audience couldn't do it either, I think we can all at least agree that in certain cases we know it when we see it. We are able to easily and relatively simply identify that thing is simple, that thing is not. But what do the simple things have in common that I've listed? What am I kind of trying to get at here? Well, it's not about features. It kind of looks a little bit like it's about features because I put up the F1 steering wheel with its 80 million switches, and the F1 steering wheel does more things than the steering wheel from a 1990 Toyota Corolla. They're not exactly the same, so maybe it could be about features, but it's not really. So if we go back to requests and URLib3, the feature set's the same. Actually, requests feature set's a little bit broader. Requests can do anything that URLib3 can do, but requests is simpler. Requests actually wraps one of the libraries that URLib2 wraps, so almost definitionally, requests is a strict superset of URLib2. Anything it can do, we can do better. I'm going to argue here that simplicity is actually not about features, it's about defaults. What simple things don't do is that they don't expose all their features as configuration toggles to their users. And I'm going to argue that this is the most important thing I'm going to say in this talk. So if my voice is boring you, or if you're still hungover from yesterday, if you just remember this little bit, you can then go to sleep, and you'll have gotten all the value out of this talk that everyone who pays attention will get out of it. I just pad. I come up with one idea, one sentence, and I pad around it. It's fine. So my contention is that to make things simple, you need to make decisions for your users. Simple things expose fewer configuration toggles to their users because they choose sensible defaults that are covering the majority of what their users require. If you kind of hop back and you think about, so requests is one solid example, but the mouse is the better one. The mouse is making more choices on behalf of the user. The mouse is saying, you don't need to choose what the DPI of the laser underneath the mouse is. It doesn't matter. We're going to choose a decent one for you. 800 DPI sounds about fine, so we'll do that. If you do really care about that, then you can get the mouse with the weird DPI toggle on the side, and then you can hit it instead of the scroll wheel and wonder why nothing scrolls. That's totally fine. But most people don't need that, so most people can do the mouse without the little scrolly DPI craziness. Alex Gaynor likes to say this a lot. If you spend any time with him, you'll find that he says this all the time. But constraints make the medium. The same is true for simple things. Is placing constraints on your tools, on the things you build, can in many cases make them more appealing than not doing that. So I've made this kind of argument that simplicity is about making choices for the user, and it's a totally reasonable thing to say, well, why is that a thing worth doing? Why is simple good? Well, the easiest answer to give is that the Zen of Python says that simple is better than complex, so tough. That decision's been made. Tim Peters wrote it down somewhere. It's fine. More generally, though, people appreciate simple things, right? Lots of other people have said basically things like this. Edgar Dijkstra said that simplicity is a prerequisite for reliability. That's good. Prerequisite's also a hard word to spell. Less is more is another common maxim you'll hear programmers throw around while simultaneously adding the 50th feature flag to their command line tool. Henry David Thoreau. I don't only have programmer examples. Simplicity is valued outside of software as well. Simplifying things is good. So, if we all think simplicity is important, how do we propose to get there? Well, I think the best way to get there is to emulate vegetables, and in particular is to take an onion-like approach to design. This is not a novel thought, by the way. Anyone who has taken really any software design education in any kind of formal form will be told that this is the way they should be designing. And so I think it's probably a testament to our inability to pay attention that most people still don't do this. But this kind of model is a really good way to design software such that you can appeal to the broadest selection of people and so that you can build simple things. So, basic principle of the onion model is that you think about the use cases for the thing you're building. You think about what is it that my users are going to try to achieve with these tools. And then you divide these things into categories. You put a nice big list and you say, these things are the standard use cases. They're the main line. These things should be simple. Then you have the other set of use cases. These things are weird. Someone wants to do something strange outside the norm. These things are complex. Generally speaking, if you want a good heuristic for this, complex use cases are costly in some dimension of cost. Now, you can measure cost in lots of different ways. Cost could be performance. Cost could be architectural complexity. Cost could be scale. But one way or another, a complex use case incurs some cost that a simple use case does not by virtue of it being outside the main stream of use cases. And the goal of this design model is to push the cost of that complex use case out so that it only affects the users who actually need it. Your users who aren't doing weird, crazy stuff with byte orientations do not need to worry about any of that, and they shouldn't be exposed to the switches that control that stuff. Anytime in a software user interface you see a switch that uses words that you don't understand, that is a failing on the part of the person who created that software, because that should only ever be found by people who wanted it in the first place. Generally speaking, you shouldn't punish innocent users for the costs of the user who demanded the weird, complex thing. Simple things should be simple. Complex things should be possible. So we're going to build in layers. I'm going to give you an example of a relatively simple model. I'm going to propose a 3-layer model. 3 layers are great. Don't be fooled by the idea that more layers are better. More layers are usually not better. 3 is a good number. We'll stick with 3. I'm going to use some examples here. I'm going to use requests as an example, again, because it's what I know. The specific example I'm going to use in order to hit a kind of nice sweet spot where I get to make a good point is something that is common but also slightly tricky, which is an HTTP multi-part post request. Don't worry if you don't know what those words are. It means you have to structure some things in a very specific way, but it's relatively common, so we're going to do that. All right, we're starting with layer 1. Layer 1 is the low-level option. When you build layer 1 of your tool, what you want to do is you want to think, if I was someone who needed to control exactly what happens with this tool, what options would I give? This should be complete control, no bells and whistles. Don't help out. Any feature you write that's helping is actually a feature that's taking control away. Your layer 3 solutions want that. Your layer 1 ones don't. In the HTTP world, for those who care, the analogy is HTTP-lib, probably the best example, http.client, for those of you who like Python 3's fetish for renaming all the modules. This is a library that knows the basic mechanics of HTTP, but it doesn't know anything about the semantic constructs of HTTP. It doesn't understand what a redirect is, for example. All it knows is there's a 3-digit number that comes back that means something weird to somebody. This layer, a good example of what this layer should be able to do, this layer should be able to support all valid use cases. Anything that the HTTP specifications allow, this layer should support. It should also probably support some ones that are invalid use cases. It should probably let you do things that are not strictly okay, but that some crazy person somewhere might have done once, and that you need to be able to replicate. The thing with this layer is, effectively using it requires really quite deep knowledge of the problem domain. How many people in this room would say that they know HTTP even moderately well? All right, it's quite a few hands. How many people in this room would say that they feel really comfortable writing their next project in HTTP-lib? How many people in this room have looked at HTTP-lib's documentation? Yeah, smaller, right? You need to understand, to use HTTP-lib effectively, you need to understand how HTTP works down at the level where you're managing individual network connections. You need to understand HTTP state machines, its framing model. You need to understand HTTP down on the wire. This is an expert-level API. If you don't know those things, this is not for you. And this is why it's not for you. So to do the multi-part upload code for HTTP-lib, you need this. And I say for HTTP-lib, there are actually 5 module imports at the top of this because we need to bring in a whole ton of other stuff from the standard library. But you have to roll everything yourself. HTTP-lib doesn't understand multi-part uploads, so you need to construct them yourself. And they have weird random strings in them, and they have crazy double equal signs all over the place. This takes a lot of code. However, all this code is about as generic as the subsequent solutions I'm going to show you. That's why there's so much of it, is it needs to handle some slightly odd edge cases. Don't worry if you can't read that. Reading it's not the point. Next layer up. So you've got your base layer. Next layer up, you want to wrap layer 1. You want to create a new interface around the edge that adds useful features and encapsulates understanding about how layer 1 is supposed to fit together. So basically, this stuff should mostly just call into layer 1 and should call into layer 1 at roughly the right order, doing roughly the right things. Here is where you want to put all your switches and options. Anything that a user might want to toggle should go in here. Configuration should be exposed. You should add your command line flags if you're having command line flags. What you want to do here is support all valid use cases, but there is no requirement that you support invalid ones at all. Anything that you validly want to do, you ought to be able to do with this tool, but anything that you might not validly want to do doesn't have to work. This layer should require users to understand what they want to achieve. And it should require users to be really, really happy configuring the software appropriately. But they don't have to know how this problem is really solved when it comes down to bit twiddling. You shouldn't have to know how HTTP looks on the wire. If we were talking about images, you shouldn't have to know how to encode a PNG file, for example. You should be able to get away with knowing the semantics of the problem, not the actual binary formatting of the problem. It's enough to know that HTTP has headers. You don't need to worry about how they're formatted. It should also be very easy to extend this level if you're designing carefully. So it should be very easy to hook in and either subclass something or compose something. Basically, pass in something that does something a little odd and weird. And in HTTP world, this matches neatly with URLlib3, a library you've never heard of. This is URLlib3. This is the layer 2 of the requests stack. Requests builds entirely on URLlib3, which itself builds entirely on HTTPlib. This has got far more helpers than the last thing did. So this has got lots of things in here about multi-part encoding. You can see there's some make multi-part calls in there. There's something called a field. Who knows exactly what that does? Content types and all that jazz. This is still a decent chunk of code, but it's helping. More importantly, you've got a lot of control here. If you need to make these fields appear in a specific order, you can do that. If you need to add weird headers to specific fields, you can do that too. If you need to control what the boundaries look like for the multi-part stack, you can control that too. You've got to be very explicit, but the flip side of that is there's a lot of control. So, layer 3, the highest level layer, and this is the layer where simplicity is your primary concern. More than that, this layer should be the default. If someone Googles how to do X in Python, and anything other than layer 3 shows up first, this is a failing. If a user, this is part of why, by the way, Python's documentation now includes on HTTPlib a note to go look at requests. It's because actually HTTPlib usually appears higher in the searches than requests does, but it's not the thing that the average user should just be picking up and using. This layer does not support all valid use cases. It is totally okay that there are things that are allowed to be done that you cannot do with this layer. What this layer is trying to do is to support the 80% use case. Support all of what most users need to do most of the time. This means you can omit support for the complicated things for the sake of improving the simplicity of the standard line tasks. Anything that gets done most of the time, you should be able to throw away the things that make it more complicated when you include the wider range of things you could do. There's one caveat here. That's only a good idea if the user can drop back down to layer 2 at any time. So if they are able to, for any reason, throw in and say, I do actually need to do the weird 90% thing, so I'm going to bring in some code from layer 2 and put that in the appropriate place. This layer should require almost no knowledge on the part of the user. If at all possible, they should not need deep domain knowledge to solve this. It's enough to get away with knowing vague semantics. If you know that GET is a thing in HTTP, you can use requests. You don't really need to know the semantics of GET. You don't need to know if it's cacheable. You don't need to know if it's idempotent. All you need to know is that GET's roughly a thing, and then you can type GET, and it works. This should do the right thing without user intervention, and this means choosing good defaults. And the goal here is to allow users to peel back the layers as they go. They should be able to start at layer 3 when they begin to solve their problem, and then work through it, and hopefully most users will just stop. Their problem will be solved. Some users will find they needed something weird, and at that point, they should be able to peel back a layer, expose the point at which layer 2 is programmed by layer 3, and do something a little bit different. In requests, we provide an object that essentially encapsulates our interface to URLlib3. It contains all the function calls that we make into URLlib3, and we expose it deliberately so that you can override it. You can say, oh, okay, the way you're calling URLlib3 here is not suitable for me, so I'm going to special case in this instance, and then you can put the onion back together, use requests over the top, and underneath, the magic will happen and do the right thing. The end result here should be layer 3 is suitable for the vast majority of users and should make them happy because, in the face of ambiguity, it does the right thing. This ends up looking like this. This is actually one logical line of code, more or less, if you ignore the import and the print, which, let's admit, we all do. You
just talk about semantics here. There's no talking about how stuff is laid out. There's no talking about what it looks like on the wire. This is all semantics. This is post, URL, and then I have some keys and some values and some files. So while we're talking about simplicity, and I'm coming to the end of this, there's one other thing we should talk about, and that's the 80% use case. Before you write a tool to solve someone else's problem, let me stop. If you're writing a tool to solve your problem, do whatever the hell you want. If you're writing a tool to solve someone else's problem, it is extremely helpful to first understand the problem domain. Understand the semantics of the problem, understand what solutions to this problem could look like, have looked like in the past, will look like again. And then come to a position on what the 80% use case is. Of the people doing this thing, what are most of them doing most of the time? And then target making that work as smoothly and as effectively as possible. Because the reality of writing software is, or everything is, you can't make everyone happy all the time. It doesn't matter what you do. Some people are going to be really mad. Some people are going to send angry tweets. They're going to write snarky emails. They're going to post something that's going to get to the top of Hacker News, and you're going to feel really bad about it. But if you've targeted the 80% use case, you can take solace from the fact that while you can't make everyone happy all of the time, you can make a smaller number of people totally ecstatic. All right, thank you so much for your attention. Happy to take questions. I have one quick note. I've given a 20-something minute talk that's predominantly my opinion. You also all have opinions, but I'm on the stage. So the Q&A period is for questions. If you would like to share your opinion with me, I would like to hear it outside after the Q&A period. Thank you.
Well done, Cory. That was a great talk. Comments?
No comments.
Sorry, questions.
Thank you.
For Chan. Oh, right at the back. Oh, bloody hell. Hang on.
Run, Nick, run.
I'm not even supposed to be here, you know.
Thank you very much. Hi. I'm just wondering, what's the sort of design process you tend to adopt with this onion model? Do you start at layer 3 and drill down, or do you start at layer 1 and try and build up?
You can do either. I find that it helps to do a little bit of both. So usually what I will do is I'll adopt what some people call README-driven development. So I will start by mocking out what I think the interfaces should look like at each layer. What do I think I need to be able to do at each point? What do I think other people need to be able to do at each point? And I'll write how I want that to work. And then I will start trying to write it from the ground up, and I will run a very tight feedback loop for the first few iterations, and I will say, okay, this is actually not going to work because the interface here becomes too clumsy, so I'll move things around, push things up and down different layers, and rewrite the interfaces. What you do want to be able to do here is be really responsive to the way each layer changes. Just because you're being simple at layer 3 doesn't mean you can't get away with taking some account of what's going on at layers 2 and 1.
More questions? Over there.
Hi, thank you. Should requests or other layer 3 libraries be part of the Python standard library? Is the fact that there are only the lower level libraries there making people do more work than is necessary for most cases?
That is an incredibly fraught question. In general, yes, the standard library should aim to be more helpful to the general use case. However, in practice, there are a number of problems with that at almost every scope. Requests, in the last Python Language Summit, there was an explicit discussion of should requests be in the standard library, where the response overwhelmingly from maintainers and from the vast majority of the standard library people was no. This is nothing to do with abstractions, simplicity, anything like that. It was a very boring technical thing about security vulnerabilities and release rates. In general, yes, I think they should. In practice, every library is special.
Okay, we have time for one final question. Short question. Oh, yeah, Alex.
So, if you found a magic lamp, genie inside, gave you a wish, what area would you like to see? And now this area, this is the library that is the equivalent of requests for domain X. Does that make sense?
Yeah. I'm a bad person to answer that question because I live and breathe HTTP. It's all I do. I think, from my perspective, I would like to see requests for the async world, actually. That's the thing I miss most. I would like requests to be the requests of the async world, but I'll worry about that later. Other than that, the best I can do is point to the ones that people may or may not know about that are already the requests of their separate domains, where I think the closest that I can think of for that, off the top of my head right now, is that I would argue that Flask is the requests of web serving by virtue of choosing not to do most of the things. I would like to see, actually no, I've got an answer. SQL would be good. SQL Alchemy is great, but it's complicated. And if every time I have to look about session objects and think about transaction isolation, I get very sad. It would be nice if someone would make these decisions for me. So requests for databases would be great.
There you go. That's something to hack on Monday then.
Yeah.
Thank you very much, Cory.
Thank you.